ladies and gentlemen, this is 7.3, our last chapter before our exam in multiplying and dividing polynomials. We started here with question 2. It says, I need to use the following method to simplify the expression. So she took this one first here. There's the expression she had. And the first thing she did was rewrite it like this, which seems very reasonable, right? And then she got this as her solution, which she made a mistake. Where did she make a mistake? The mistake she made was when she thought about this here. What she needed to think was dividing the coefficients and dividing the variable terms, which, since there is no variable in the denominator, we can think of as 1. So when she did this and got 3k, she divided to get 3 over 1, which is correct. She got the right coefficient, but k squared divided by 1 is not k, it's k squared. Likewise, when she did the 3k divided by 3, she needs to divide the coefficients, which she did to get -1, but the k divided by 1 still does the k, so it should be 1k, or more appropriately, 3k minus k, or 3k squared, sorry, 3k squared minus k. Question 4, what division statement is used? So again, if we think about this as a rectangle and the area was 10 and the side was 2, we know that this is going to be 5 because the area divided by the side we know equals the side we don't. So therefore, if I take that same method for all of these questions, the area is 6x squared plus 4x. That's the area divided by the side I know, which is right here, which is 2x, equals the side I don't, which would be 3x's plus 2. I don't think you need, determine the quotient yet. You do need the answer as well. For this one, area is 4x squared plus 6x divided by the side I know, which is 2x, will equal, those are all positives as well, 2x plus 3. And the final one, the third one, the area, which is 6x squared minus 3x this time because they're not shaded in, divided by the side I know, which is 3x, equals the answer, which will be 2x minus 1. Do we do question 5? No. Do we do question 6? Yes. Divide each expression using a model. So for this one, A, I'm going to draw my area. Now, I can't start with my area. I'm going to start with my side length of 5x, so 1x, 2x, 3x, 4x, 5x. Shade those in solid. Sometimes my x's are nice and long, sometimes they're just kind of stubby. Now I'm going to put some lines over here, and I'm going to figure out, based on these lines, how my area is going to go in there. I need to get 5x squareds. So if I put a line there, I now have my 5x squareds. There they are there. They're all positive, so there's x squared. I need negative 10x, so I put a line down there, I get 5 of them. I put a line there, I get 10 of them. Erase my superfluous lines that I do not need for the area. And that is the area of 5x squared minus 10x. And therefore the solution is a positive x and a negative 2. In B, we'll start with our area again. Put down my 2x here, so 1x and 2x. The side I know. Put some lines over here. Hopefully I have enough space here. 4x squareds, there's 2 of them. There's 4 of them. And now I have to get 12 x's. There's 2, there's 4, there's 6, there's 8, there's 10, there's 12. Erase my lines. Those are all solids. So I can actually just take a highlighter here and just shade them all in solid because we know they're all solid. They're all positives. My missing side length is x and x and 1 and 1 and 1 and 1 and 1 and 1. Or 2x, and those are all solids as well, plus 6. Any questions on 6? We're okay? Everybody's good? Avery, good? Question 8 says divide. It does not say divide using modeling, so we're just going to look at, that's not even the right question. 2y squared divided by 2y, and 4.2y divided by 2y. We're going to break it up into the addition of these two parts, which we're going to reduce. That's just going to become a y. 4.2 divided by 2 is 2.1. Y divided by y cancel each other out. My solution is just a y plus 2.1. Ooh, our first trinomial. This is exciting. So it's 12m squared divided by 2, negative 6.2m divided by 2, and 24 divided by 2. This will become 6m squared. This will become negative 3.1m, and this will become a positive 12, and my solution is 6m squared minus 3.1m minus 12. Question C, negative 18y squared divided by negative 6y, and negative 6y divided by itself. Ooh, that's an easy one. When we work this out, this is going to be a positive 3y, and this is going to be, it doesn't even matter what it is, any number divided by itself. We know those are identical things, and we've learned that 24 divided by 24, 116 divided by 116, negative 12 divided by negative 12 will always be a positive 1. So any number divided by itself is 1, and therefore the answer is 1. And finally, our last one will be this, and it will be this. This will be 1. That'll cancel each other out, leaving me with just v. Negative 2.7 divided by 3 is negative 0.9. C divided by C cancels each other out. I end up with a binomial v minus 0.9. Question 10. It says a dump truck holds 10 cubic meters of soil. You are filling a rectangular space in a yard with the dimensions of 2x plus 3 by 5x by 2 in meters. What polynomial expression represents the number of truckloads of soil you need? So the first thing you should have probably done is drawn the soil. So there's a little tree here. Little rabbit lives here. Yada, yada, yada. There's the soil. The length, the width, and the height. So the length is 2x plus 3 meters. Who knows what x is, but that's the length of it. The width is 5x, and the height is 2. So once you drew your dirt, you had a rectangular prism filled with dirt. And there's a truck, which I will poorly draw as such. Thank you. It's a truck. There's Jack in there smiling. And the truck holds 10 cubic meters of soil. We'll just make it 10. The question is how much soil goes into there. So the first thing I want you to do, and the first skill I want you all to have, is this looks complicated. If you can't solve this, let's think of an easier question first. What if I gave you the same question, but instead of having algebraic, I said this is 8 by 4 by 2. Okay? And then I asked the same question. The truck has 10 cubic meters. If this was the dimension, you would first calculate the volume by using the formula you learned in grade 8, area of the base times the height of the prism, or 8 times 4 times 2, or 32 times 2, or 64 cubic meters of soil would be in that easier one, correct? And if I wanted to figure out how many truckloads, if each truckload holds 10 cubic meters, Andrew, of soil, how many truckloads would it take to fill that area? 6.4 truckloads, right? You would take this and you would divide it by the truck to figure out that it's 6.4 truckloads of dirt that would go into it, right? This is a grade 8 question. The grade 9 version asks you to think a little bit more abstractly. So what we're going to do is we're going to multiply the area of the base. So it's still going to be length times width times height to calculate the volume of dirt in that little area with the rabbit and the tree. I could put my binomial first. I'm going to switch it up. I'm going to go, is that going to, because of the associative property, you agree that's not going to change the product, right? So we're going to go monomial first, multiplied by binomial. It will not affect the product because of the associative. And that represents the area of the base, multiplied by the height of the prism. 2. When I expand this using distributive property, I'm going to get 10x squared plus 15x multiplied by 2. Or if I want to think of that even better, because of the associative property, I'm going to double that. I can actually put a 2 out there now, right? I'm going to double it. You could keep it back there. It doesn't matter. You're just going to have to double. Just remember, if you did it this way, if you did have your 2 over here, you still have to use distributive property this way as well, right? You can still do it that way. Or if you want to switch it around, because the associative property, it doesn't matter the order in which you do it. Most of you like the look of this better because you're used to it. But you can do it either way. Either way, you're going to get a volume of dirt plus 30. Plus 30. That's the volume of dirt. Okay? So it's 20x squared. 20x squared plus 30 is the volume of dirt. Now, if each truckload contains 10 cubic meters of dirt, then you take the volume of dirt and you would divide it by, just like we did here, right? Just like we did there to figure out how many truckloads it is. You're going to divide it by what one truck can take, which is 10, and you're going to get your solution. Can I do anything with that? Can I simplify that? Can I simplify 10x cubed plus 30 divided by 10? Yes, I can simplify it because I can use distributive property here. I'm going to divide both of those terms of my volume of dirt by 10, give me 2x cubed plus 3. So therefore, and this is the abstract part, the number of truckloads of dirt, number of truckloads is 2x cubed plus 3 truckloads. And people are like, that doesn't make sense. That's not a number. Well, it is a number if I give you a value for x, isn't it? What if I told you x was 2? What if I told you x is 2? Then you would say, well, that's 2 times 2 cubed plus 3 truckloads, or 2 times 8 plus 3 truckloads, or 16 plus 3. That's 19 truckloads of dirt if x is 2. If x is 3, that becomes 2754. That's 57 truckloads if x is 3. And if x is 100, that's a whole lot of truckloads, right? So when x has a value, we can then determine the exact number of truckloads. But algebraically, it's that many truckloads right there. That's your solution. Question 11, almost the exact same question as question 10. It says a rectangular fish tank has the dimension shown here. The volume of the tank can be represented by this. It tells you that the volume of this tank, meaning the amount of blue water that's in this tank right up to that level right there, not full, because you can tell it's not full, but the volume of that is 7.5 W squared minus 3 W cubic meters of water. What polynomial represents the area of the base? So, first thing I want you to do is start with your formula. Because it's a rectangular prism, that's our formula for the volume of the rectangular prism. Which one don't we know? The L, the W, or the H? We don't know we don't know the L. So I'm going to put in everything I do know. What's this one? It's given to us right here. The volume of the tank is this. So I'm going to replace the variable V with the actual volume it gave me. That's the first step. What is the length of that base? We do not know, so we're going to keep L. What is the width of the base? It's W. And what is the height of the base? 0.6. So when I substitute that, I end up with that particular expression. Now it says, what polynomial expression represents the area of the bank in the tank? So would you all agree that this expression represents the area of the base, right? Is it isolated? Is that LW by itself? No. What's with it? 0 multiplying by 0.6. So if I want to create an expression that does not have this part right here, how do I get rid of it? Algebraically. How would I get rid of it, Padme? If I want to get rid of a multiply by 0.6 in an algebraic equation, how do I get rid of a multiply? Divide both sides by that number. So if I divide this side by 0.6 and divide this side by 0.6, you would agree I now have a formula, because it's now isolated, for the area of the base. Would you agree with that? That's the A. That's the answer to A. So the answer for A is this. This is a formula for the area of the base. Okay? Now B says what polynomial expression represents the length of the tank? So if we take this expression, what it's asking me is, can we isolate the variable L? Can we create a formula that is a isolating of L? What would I do for this one if I wanted to isolate that variable L? Oh, by the way, first of all, is this simplified? Is this expression simplified? I should have said that first. Let's go back in time. Hang on. Before I get so excited, is this equation, is this formula in lowest terms? Can I reduce it? How? If I utilize distributive property, can I divide both terms by 0.6? Yes, I can. Right? I can think of it as being 7.5 w squared divided by 0.6. Take my calculator. 7.5 divided by 0.6 is 12.5. That works. Would you agree that the first term, will be 12.5 w squared when I divide it by 0.6? And the second term, if I divide negative 3 by 0.6, I should get 5. Negative 3 divided by 0.6 equals negative 5. So the important thing here is realizing that once you wrote this formula here in blue, you had to use distributive property to simplify it to lowest terms. So this is actually your answer to A, right here. That is a formula for the area of the base. Now B says, what is a formula just for the length of the tank? So we're going to take this whole formula right here, and we're going to simplify it by isolating for just the length of the tank. Jack, what would I do to isolate for the length? If I want that L to be by itself, what would I have to do to both sides of that equation to get it by itself? Divided by what? Correct. If I divide this side by W and this side by W, algebraically speaking, from your experiences, we know it still maintains equality. But the beautiful thing is, I've now isolated for the length of the tank, right? So the formula for just the length of the tank is this. Is that in lowest terms? I can reduce that now, can't I? Avery, what would I do here to make sure that that formula is in lowest terms? I have to use what? Distributive property, that's right. So I'll take this term and divide it by W, and this term and divide it by W. What will 12.5 W squared divided by W become? TO. If I divide 12.5 W squared by W, what will it become? Just 12.5 W. And if I divide negative 5 W by W, what would I get? Just negative 5. So therefore, for B, your solution for the formula for just the length will be 12.5 W minus 5. Does that make sense? All right, last question in that one says, what is the length of the tank if the width is 0.6 meters? What is the length of the tank if the width is equal to 0.6 meters? How long, non-algebraically, is the tank? Hayden, what would you do for that one? If I wanted to figure the actual non-algebraic length of the tank, this is the algebraic length of the tank, isn't it? But how do I figure the numeric length? If it tells me that the width is 0.6 meters, how am I going to figure how long it is? Correct. I am going to take the value of that width and substitute it right here. So I'm going to take my equation and go 12.5. Instead of 12.5 times W, I'm going to do 12.5 times 0.6, which is the width. That's going to equal the length, right? Which is going to be 12.5 times 0.6 is 7.5. What's 7.5? Take away 5. 2.5. So therefore, if the width is 0.6 meters, then the length of that tank will be 2.5. Boy, question 13 in relation to the last one we just did is so much easier. It just says, what's the length? Andrew, how do I get it? So the area divided by the side I know equals the side I don't. Or the area divided by the side I know equals the side I don't, which will be, what's 3x divided by 9x squared? It's just 3x. What's 3x divided by a negative 3x? Negative 1. Not x. Negative 1. So therefore, there's my answer. If I want to check my answer, the length times the width should equal this, which it does, and therefore is correct.